Hello everyone, welcome to this video tutorial series on D04 microcontroller based system design lab course. In this session, we are going to learn about how to interface 7 segment display with PIC18F4520 microcontroller. But before interfacing, we will just learn about how our 7 segment display works. So as you can see in this picture, there are 8 LEDs. By using that, you can able to form a 7 segment displays, and these 7 segment displays can be used to show digits from 0 to 9. So there are 8 LEDs, LED A, B, C, D, E, F, G, and there is another LED for decimal point. There are commonly two types of 7 segment displays. One is called as common cathode and another is called as common anode. As you can able to see in this particular picture, the cathode terminal of all the LEDs are connected to the same terminal, and this terminal is get connected to the ground. So if you want to turn on this LED, let's say A LED, then you need to provide a logic 1 to this A terminal. At that time your LED will turn on. If you connect this terminal A to the ground, it means that your LED will be turned off. We will just see one example. As you can see over here, so all these 8 LEDs, the common cathode terminal is connected to the ground, whereas these A, B, C, D, E, F, G and DP are nothing but the anode terminals of your 7 segment displays, and these are connected to these buttons. So as you can see, the other end of button is connected to either VCC or a ground. So if I just simulate it, as you can able to see, all the buttons are get connected to the logic 0, which is 0 volt. Now if I want to turn on this LED, we have to provide logic 1, which is nothing but the plus 5 volt. So if I just change the status of this, as you can able to see, A LED has been turned on. So this way you can able to turn on all these LEDs by providing logic 1 to the particular LEDs. So using this display, we can able to show 0 to 9 digits. So in this schematic, you can able to say, let's say we have connected these common cathode to the port D of PIC18F4520. A is connected to the RD0, B is connected to RD1, C is connected to RD2, D is connected to RD3, E is connected to RD4, F is connected to RD5, G is connected to RD6 and DP is connected to RD7. So out of which DP is the MSB bit. So we will just write this into our table. So DP is our MSB bit. Then we are having G, F, E, D. So G, F, E, D, C, B and A. So in this particular table, DP is the highest possible number, whereas A is the LSB. So most significant number bit is DP, whereas A is the LSB. So suppose if you want to show 0 on this display, it means that you need to turn on A, B, C, D, E, F, whereas G is turned off, and we are using common cathode. It means that whichever the LED you want to turn on, you should provide logic 1 to that LED. So in our case, we are turning on A LED, same B, then C, D, E and F, whereas D, P and G are turned off. So we are going to provide logic 0 to both these LEDs. Using this table, we can able to find the hex code for our 0 digit. So the hex code for this 0 digit is 0x and 3. This is 3 and this is F. Now same way we can able to find the hex code for 1. Now if you want to show one digit onto this 7 segment displays, at that time we need to turn on LED number B and LED number C, whereas other LEDs will turn off. So we will just provide logic 1 to LED B and C, whereas other LEDs will be turned off. So the hex code for this is 0x. This is the 0th higher nibble, so let's say 0, and the lower nibble is 6. Same way, if you want to show the 2 digit onto this common cathode 7 segment display, you need to turn on LED A, B, G, E and D, whereas F, C and DP are 0. So DP is 0, F is 0 and C is 0, whereas other pins are at logic 1. So we will get hex code as 5, then this is B. Now same for 3, we have to turn off this F and E as well as DP. So F will be turned off, E will be turned off, DP will be turned off, whereas other LEDs are turned on. So we will just provide logic 1 to those LEDs. Now we will get hex code as 0x4F. Now same way we can able to find the hex code for all the digits up to 9. So let's say we will find the hex code for 4. So at that time F, G, B and C will be turned on. So F, G, B and C, whereas other LEDs are turned off. So you will get hex code as 0x66. Now for 5. So for 5, the A LED will be turned on, F will be turned on, G will be turned on, C will be turned on and D will be turned on, whereas E, B and DP are turned off. So B is turned off and E is turned off. So whereas other LEDs are turned on. And the hex code for this digit is 0x6 and this is 13, which is D, 6D. Now we will see for digit 6, which is F, G, C, D, E and A will be turned on, whereas B and DP is turned off. So we will just turn off the B and DP, whereas other LEDs are turned on. So the hex code for this is 0x7D. Now for 7. For 7, LEDs are turned on are A, B and C. So A, B and C, whereas others are turned off. So the hex code for this is 0x07. Now for 8, all the LEDs are turned off except DP. So 0, whereas all the LEDs are turned on for digit 8. So the hex code is 0x7F. Now for digit 9, only E and DP are turned off. So DP is 0 and E is 0, whereas others LEDs are turned on, so that we are supposed to provide logic 1 to them. So the hex code for this digit is 0x6F. Now by using this hex codes, we are going to provide these values to your port. So for that, we are going to create a project using MPLABX IDE. So just go to File, New Project, select Standalone Project, click on Next. Now type for PIC18F4520 microcontroller, select that, click on Next, select X8 as a compiler toolchain and provide the name, let's say 7 segment display and common cathode. Just click on this finish. Now we will create our source file. So right click onto the source file, under new select main.c and we name it as ssd_cc common cathode. Just click on finish and you will get a .c file with name of ssd_cc.c. Now first of all, we need to configure the bits. For that, you need to go to production, set configuration bits. Over here, you need to configure your oscillator. So we are going to use HSPLL oscillator. We are not using any other peripherals of PIC18F4520. So those peripherals we are going to turn it off. So we are just turning off all the peripherals. So generate the source code and copy the codes which is generated by this tool and paste it over here. First of all, we are going to define the frequency of your microcontroller by using XTAL keyword, XTAL FREQ and the frequency. So the frequency is 40 megahertz. Now we are having these hex code. So what we will do is we will just declare one array which stores these numbers. So we will declare, let's say, char cc of 10 numbers and the values are these. So the first value is 0x3f, second value is 0x06, third value is 0x5b, comma 0x4f, then 0x66, then 0x6d, then 0x7d, then 0x07, 0x7f and 0x6f. So we have just declared one array. Now we are going to use this array to transmit these particular hex code to the port. So as we have seen in this diagram over here, these pins or this 7 segment display is connected to the port D. So if you can able to see in the schematic, the common cathode is connected to the port D. So we need to configure port D as output. So over here inside main, we are going to configure the port D as output by using trace resistors. Trace D is equals to 0x00. So port D is configured as output. Now we need to declare one variable for using the loops. So let's say int I is the variable that we are going to use. Now inside while 1, we are going to write the numbers from 0 to 9. So we are going to use for loop for the initialization value of I is 0, semicolon, I is less than 10, semicolon, I plus plus, and inside this for loop we are going to transmit these values to the port D. So that's why we are going to say let D equals to Cc of I, and there will be some delay so that we can able to see the numbers. So let's say 1000 milliseconds. Now we are going to just compile it or build it and see whether there are any issues with the code or not. Now this code is successfully compiled, as you can able to see in this output box. Now we are just going to simulate this particular circuit. So for that, just double click on this microcontroller and see where your hex file is stored. So in our case, the hex file is stored at this particular location. So we are going to this PC, users, does, MPLabX project, SSD, distribution, production, and ssd.hex. So we are just going to open it and okay. So if you just run it, you can able to see the digits are printing onto the your 7-segment display, which is nothing but the common cathode. So this way you can able to interface your 7-segment display. Same way you can able to interface common anode. Now in this diagram you can able to see the anode terminal of all LEDs is connected to the common one, and this common terminal is get connected to the plus VCC, which is nothing but the plus 5 volt. So if you want to turn on these LEDs, you need to connect cathode of these LEDs to the logic 0. So suppose A, B, C, D, E, F, G and DP are connected to the logic 0. At that time all the LEDs will turn on. So we will just see one example how we can able to use this for common anode. So as you can see, all the LEDs initially are off. Why? Because the terminal of these LEDs A, B, C, D, E, F, G and DP terminals are connected to the plus VCC. Now if you connect these terminals to logic 0, which is ground, at that time your LED will turn on. And same way if you just turn on another, you have to connect this terminal to the ground. So as you can see in this picture, we have connected the common anode 7-segment display to the port C of PIC18F4520 microcontroller. LED A is connected to RC0, LED B is connected to RC1, LED C is connected to RC2, D is connected to RC3, E is connected to RC4, F is connected to RC5, G is connected to RC6 and DP is connected to RC7. So out of this, DP is again the MSB bit, whereas A is the LSB bit. So as you can see in this diagram, we have connected this common anode to port C. So now we will just find the hex code for this common anode. So again, your DP is the MSB, so we are going to write DP, then G, F, E, D, C, B and A. So DP is the MSB, whereas A is the LSB, and we are using common anode over here. So if you want to turn on the LEDs, you need to provide logic 0 to these particular LEDs. So suppose if you want to show digit 0 onto this common anode 7-segment display, at that time you need to provide logic 0 to A, B, C, D, E and F, whereas G and DP will be logic 1. So we will just write the values 1 to DP, G to 1, whereas other values are 0 0. So the hex code for this is 0x, the higher nibble is 12, which is nothing but the C, and lower nibble is 0. So the value is 0xC0. Same way you can able to display digit 1 onto this common anode 7 segment display. So if you want to display 1, you need to turn on LED B and C. So the value of B and C is 0 0, whereas other values are at 1. So the hex code for this is 0xF9, because higher nibble is 111, whereas lower nibble is 9. So if you want to show digit 2 onto this common anode 7 segment display, you need to turn on LED A, B, G, E and D, whereas F, C and DP are turned off. So DP, F and C are turned off, whereas other LEDs are turned on for digit 2. So the hex code for this digit is 0xA4. Now same way we can able to find the hex code for digit 3. At that time you need to turn off F, E and DP LEDs. So F is turned off, DP is turned off and E is turned off. So the value is for other LEDs 0 0 0 0, and the hex code for this is 0xB0. Now same way we can able to find the hex code for digit 4. So we need to turn off LED A, E, D and DP. So LED A, then E, D and DP, whereas other LEDs are turned on. So the values are 0 0 0 0. So the hex code is 0x99. Now for digit 5, the LEDs are turned on as A, F, G, C and D, whereas B, E and DP are turned off. So DP is turned off, E is turned off and B is turned off. So we can write 0 to other LEDs. So this way we can able to find the hex code for 5 digit, which is nothing but the higher nibble is 9 and lower nibble is 2. Same way we can able to find the hex code for digit 6. So if you want to show digit 6 onto this display, you need to turn off B LED and DP LED. So we are just going to turn it off, DP and B, whereas other LEDs are turned on. So the hex code for this is 0x82. Now same way we can able to find the hex code for 7, 8 and 9. For 7 we need to turn on LED A, B and C. So A, B and C, whereas other LEDs are turned off. So the hex code for this 0xF8. Now for digit 8 you need to turn on all the LEDs except DP. So value of each LED is 0 except DP. So the hex code is 0x80. Now for digit 9 you need to turn off LED E and DP. So the value of LED E is 1, value of DP is 1, whereas other LEDs values are logic 0, which is nothing but the ground. And the hex code for this is 0x, higher nibble is 9 and lower nibble is 0. So we can make use of these hex codes to interface with your common anode 7 segment display. So we'll just write the code for it. As you can see in this particular diagram, we have connected common anode to the port C. It means that we need to configure port C as an output. So we will use the same project. Over here we need to configure your character array. So let's say CA with the members of 10 equals to, and those value that we have calculated in this table. So the first value is 0x C0, comma, second value is 0x F9, third value is 0x A4, fourth value is 0x B0, next value is 0x99, after that 0x92, 0x82, 0xF8, 0x80 and 0x90. Now we will configure port C as an output by using trace resistor. So trace C is equals to 0x00. So port C is configured as output. Now we are going to write these value to port C. So we will just going to call over here LATC, which is a lat register which is used to write to port. So equals to CA of I. So we will just build this project and see whether there are any issues with the code or not. Okay, so there are some issues, so we will just find. Okay, so there is one error is there, so you need to just, so over here, so 0x. So now if you just build it, you can able to see if there are any errors or not. So there are no errors at this moment, and our hex file is stored at the same location as we have stored see in the last example. So again we will go to this simulation and we will start the simulation. At that time you can able to see we have configured your port C as a output, and we have connected common anode 7 segment display to this port C of PIC18F4520. So this way you can able to interface both types of 7 segment displays using this technique. So in the next session we are going to see how we can able to configure or interface a multiplex 7 segment display.